So the questions that comes into our mind, what is calibration? And why we need these calibrations to develop some production models? Why we need this concept? Now let's just see. Now let's see this thing into step by step. Okay, suppose let's try to compare these things through the classifications. Already in supervised learning sections, we have learned various kind of classifications regression model. So let we have considered two class classification model. Let two class classifications model we have. So in this two class classifications model, the output yi, the output will be lie on the either 0 or 1. We have already known this thing. So the output will be either 0 or 1. So we have already known. Now, let we have some data sets D train. Let we have some data set, let it D train. So in this data set, it is xi, yi. Okay, in these data sets. And based on this data set, we have developed some model. Let we have developed some model. Model is look like this, f of x. This is our model. This is our model that we have built using this simple D train data set. Okay, and it is a classifications model actually. Now the questions, after training the models, we need to find it what will be the output for a query point after doing this job, after training this model. So suppose for a query point xq, and we have to apply this query point onto it model f of xq, and we got some output y. Okay, and this yq will be either 0 or 1. Means and that's yq actually depends on the accuracy of our model, how much accurate of our model is. It will be either 0 or 1, 0 or 1. This yq value will be this value. But the question is, this yq may not be always correct. There may have some there have some wrong predictions, because all the model that we have going to build is not always correct for all the data sets. So in such cases, instead of using the for a classification, instead of using this concept 0 or 1, if we use some probability concept here, then the analyzing for this model will be more better. Okay, so in these cases, instead of using 0 or 1, if we use some probability concept, okay, like that, like for probability of the output yq, it will be 1. What will be the probability for a given query point xq and for a given model f? If this probability somehow we can find what will be the exact value of this probability, then this output will be more realistic than this one. Okay, instead of using simple 0 or 1, if we use this probability concept, that will be give our most value this model. So if you remember the naive Bayes classifier, already we have completed the naive Bayes classifier. If you remember, naive Bayes classifier, we have simple using the concept of the conditional probability Bayes theorem, and onto this, based on this Bayes theorem, we have developed this classifications algorithm. Okay, if you remember, in naive Bayes, we have to find the probability of OIQ equals to 1 for a query point, given query point xq. This value will be proportional to the what value? If you just remember, I strongly recommend you, if you forget this thing, please revisit the naive Bayes chapter, then you will find it. OIQ is equals to 1 into pi of I is equals to 1 to d. This is for responsible for this I is responsible for dimension, and probability of xqi given equals to. This is a simple thing that we have seen already in the naive-Bayes classifier chapter, and similarly for probability of this will be probability of this value will be probability of yq equals to 0 for a given class level. Query point xq, this value will be similar formula. We have already known this. Probability of x ui, this formula we have already seen. Okay. Now the question is, in this naive we have not got the proper probability value. Here we got the some approximate value. Just see these things. Here it's proportional sign there. Okay, means the probability that we got is some approximation value. Okay. Now based on this comparison, we'll come into some conclusions based on the conclusion. If suppose if we got this type of probability of yq is equals to 1 for a query point xq, if we got this output is greater than is equals to probability of yq is equals to 0 for the given query point. If we come into this output, then we can conclude that our class level or yq is belongs to class 1 or yq does not belongs to class 0. We can conclude this thing, okay, because of this using this. But this probability is not the accurate probability, it's the proportional value. That's the drawback of this thing. Simple, we cannot use this probability on the here. You can conclude certain in IBS, so we have already computed these things, but it is not applicable here since we have got here some approximate value. Okay, now let's try to understand what is calibrations. I think you will understand the drawback of the IBS, why we cannot use this thing. Okay, now let's try to what is calibration. Let's try to understand this. What is this calibration concept? So calibration is just think the model we have built for the query point xq. For this model we have to predict the yq. That's the job that we have to do in the classifications model. That's the job we have to do. So in this model, this output, this yq may or may not be actual always correct. This output may or may not be always correct. It's the situations. Since we have predicted these models for all query points, this output of all query point, this output may or may not be always correct. Okay, so in such scenario, since it is may not correct always, in such scenario it will be better if we use the probability concept here. Since instead of using this output to find the accuracy, if you use this probability concept, probability of iq for a query point xq and for a model f. If we find this probability and based on this probability we will got some decisions, we will get the decisions of the models, how much accuracy of the model is. So this kind of informations will give us more realistic output, okay, instead of using this concept in our calculated the accuracy. Okay, I think you will got the point. But in naive Bayes, calculated this value in naive Bayes, it is not always, it is not always correct. Since here apply here the approximate value on this probability. So this is the main problem. So to find this probability, just write it. To find this probability using naive Bayes, it not give us correct probability. Probability value, since naive Bayes is giving some the approximations value of this probability. Just see it, proportional value. So using simple naive Bayes, it not be a correct method. So because of this reason, we need calibration. We need to build another model that will give the output like a probabilistic way. That's the thing actually called the calibration. I think you got the idea. Okay, what is calibration? So you got the idea. Now let's see why. Why do we need it for calibration? Let's see. The question says, why do we need for calibration? Why do we need it for this calibration? Let's see why actually we need. So suppose late we are after some model, means after making some models, at the end of the day we have to make the minimization of the loss functions. That's the actually job we have to do. So minimizing the loss functions is give us the more accurate value. Okay, suppose we have considered here the two class log loss. Since we have already know, so because of easy of our understanding, we have considered it here the two class log loss. So if you remember, what will be the formula of the two class log loss? So if we have the n number of data points, this formula is 1 by n, I is equals to 1 by n. Just if you forget it, please go this chapter and recap this video. Then you will understand these things. Probability of pi plus 1 minus yi into log of 1 minus pi. This thing and this summation will be on this value, this summation. Okay, on this. Already we have seen. And what will be the pi here? So pi here is simple. Pi is equals to probability of yi is equals to 1 for a given point xi. This is the pi. We have seen already. This is the log loss of the two class log loss. This is the simple formula of the two class. And when we discuss the case study, then we will see how these things are actually calculated in the real data. We'll see these things when we discuss the various case study. Now let's try to understand. This is suppose our two class log loss formula that already we have seen. Now for a given query point xq, for a given query point xq, at the end of the day we have to find what will be the output of this query point by simply using the some model that we have built and apply onto this query point. We have to doing this job at the end of the day. At the end of the day, we have a query point, and we on some model, on some predicted model, we have applied this query point. We have to find it out. But this output is not always correct. So instead of using this output, if we make some another model, that will give some probabilistic output. Means such kind of probability of yq is equals to 1, what will be its output given xq, or probability of xq is equals to 0 for a given question. If this count of output that will give, then this kind of analyzing will be more accurate than this output. So here using this output YQ, we have to build another model. That model is called the calibration model. That model is called the calibration model. We have to build this model using this query point, and on this calibration model give the output like that, in that way. Okay, this is the simple model. This is a simple model, ML model, and this is called the calibration model. This is simple called the calibration model. Okay? I think because of this reason, since this model we give the only output 0 or 1, it will not give any probability value for a corresponding output. So if we using this output of that model, if we build some another model that will give the output like in probability way, that's the thing actually called the calibration. Okay, I think you got the idea what is calibrations and why actually we need it in the real world problem. Okay, when we discuss various case study and we apply onto this case study this kind of calibration technique, then you will see how much important it is in real world scenario.